Okay, welcome to another video. This time we are looking at the final of the 2D shapes we're going to look at to begin with, which is the trapezium. I say the final one of the shapes. We are going to look at circles in a little bit, but at the moment when we talk about 2D shapes we are talking about polygons, we're talking about shapes with straight edges. Okay, so let's start off by looking at what a trapezium is. Here's an example, or four examples, of different types of trapeziums that you might see. The most important thing that you have to remember about a trapezium is that it's defined by having a pair of parallel sides. You might have more than one pair of parallel sides, so for example a rectangle or a square is an example of a trapezium, although we wouldn't normally call it a trapezium, we'd call it a rectangle or we'd call it a square. In these first three examples we see that we've got pairs of parallel sides which are moving vertically, but don't get drawn into thinking that's the only way you'll see a trapezium. This last one, for example, has a pair of parallel sides going up and down the way. So we then look at a formula that we're going to use in a little moment to work out the area of a trapezium, and that's based largely on the lengths of these parallel sides, and in the formula we call that A and B. Okay, so again, in these first three examples, A and B are the sides moving horizontally, but in this last one, A and B are the vertical distances moving up and down the way. So that's about to become a little bit more relevant, because the next thing we use to work out the trapezium formula is we use what we call the height of the trapezium. We use the letter H for that. And in these early examples, the first three, that's pretty straightforward. The height is the distance from top to bottom of the shape. But the height is not actually defined as that. The height is the distance between the two parallel sides. So I might think to myself that the height of this trapezium is the distance from here at the top to the bottom, and I'm going to use this dimension A twice in my formula, but the height, remember in this case, is this distance here. Okay, H for height is just the distance between the two parallel sides. Okay, let's look at the formula itself. Okay, before I do the formula, I just want to remind you, we talked about this in class, that if for whatever reason you can't remember the formula, well, there's a couple of other ways you can work out the area of a trapezium. I could split it diagonally into two triangles, and I could work out the area of those triangles individually and treat it like it were a composite shape. Or if I was in a composite shape mood, I might split it down here and down here to give a rectangle and two triangles and add those up. Those are perfectly valid ways to find the area of a trapezium if you forget the formula. But I'd like to think the formula is probably a better way of doing that. It's going to make your life a little bit easier. So remember, we had A and B for the distance on our two, and let's put the arrows in to remind us that they are parallel sides. And we also had the distance between A and B, which we called H. I'm now going to give you the formula, and this is what we want to try and remember. So the area for a trapezium is going to be half times the height, or half times all of this. We write the half height first, multiplied by, and then what we're going to do is we're going to use a bracket, because we're going to add A and B. But I want to add A and B first of all, before doing anything else. Okay, so to try and remember that, we think it's kind of like the triangle formula. You know, we think about splitting it into two triangles, so that's where the half of the height comes from. And we have to add A and B, so that's why we use our brackets. Again, I've gone through in class where this formula comes from. If you're stuck and you want me to show you that, come and talk to me in class and I'll do that with you. Okay, so let's just show the example of how I'm going to lay this out, how I'm going to do this. Let's use this trapezium and let's just write the dimensions that I'm going to use in blue. Let's call B, let's call that 12 centimeters, and let's call A 8 centimeters, and let's call H for the height 5 centimeters. And if you think back to our earlier talk about the area of a triangle, we might want to do this multiplication in a slightly different order. We'll see in a wee second. So imagine that I have wrote this formula out, and I'm now going to write out the line where I substitute into it. So I have A for area is going to be a half times the height of 5 times A plus B, which is 8 plus 12. So that's still, I'm going to do my board mass, so it's half times 5 times 8 plus 12 is 20. Now the numbers here are still quite manageable, so I could do this. I could do half times 5 for 2.5 and work out what 2.5 20s make, but it's probably easier for me to either do a half of 20, which is 10, and then multiply that by 5 to get 50, or to do 5 times 20, which gives me 100, and half that to get 50 centimeters squared still. But if I was to do a half of 5, which is 2.5, 2.5 lots of 20 will still give me 100 centimeters squared. But if the numbers were a little bit more challenging than that, then you want to try and avoid using those decimals as much as possible. So the area of that trapezium there is going to be 100 centimeters squared. So by this stage you can now handle all the polygons that you need at the moment. You can handle squares, rectangles, parallelograms, you can handle triangles, you can handle rhombuses and kites, and you can now also find the area of a trapezium. So in a little bit I will upload some more videos for you. Next of all, we're going to start looking at volume of 3D shapes, starting with cuboids.